All right, going on to Chapter 8 as we review for our final exam. This is a typical quadratic equation in function form. State the number of real number solutions. Well, it's a real number solution when it crosses the x-axis, and we see it's crossing it there, and it's crossing it there. So, there are two real number solutions. State whether this letter A here is negative or positive. Well, if it opens upward, it's positive. If it opens downward, it's negative. So this one is negative. And determine the maximum function value of f. Well, it would be right there at 3. Okay. So actually we didn't cover this in our course, but some of you may remember that. Okay, they're asking us now to solve these. And remember, there are various methods for solving. We could solve by putting it in standard form and factoring, if it factors. Or we can solve it by completing the square, or using the quadratic formula. So for this one, it doesn't factor. And completing the square, well, we could solve this by another method too, which is similar to completing the square, where we take the 9, bring it over, and then we have 7x squared, and then we divide both sides by 7, and we get then x squared equals 9/7, and then we take the square root of both sides, plus or minus the square root of that, and in a sense that's what x is. But let's fiddle with it a little bit. So if we take the square root of 9, we get 3, and we're left with, in the denominator, the square root of 7. But we don't want anything to be left with a radical in the denominator. So we rationalize the denominator by multiplying it by 1 in the form of the square root of 7 over the square root of 7. So this ends up being plus or minus 3, the square root of 7 over 7. All right, that's that one. This one, again, you'd have to complete the equation on this side by getting rid of the parentheses and then integrating this over to that side. So that would be just a little tedious, but again, we want to show you technique here, not necessarily what the answers are. So for something like this, you could complete the square. Not a good idea because you get fractions here. But you could use the quadratic formula. So this is 1, A is 1, B is 5, and C is 7. So let's do that. So this then becomes negative B, so a negative 5, plus or minus B squared is 5 squared, 25, minus 4A, which is 1, and C, which is 7. So this is a negative 28 plus 25 gives you a negative 3. All right, this is sort of the answer, but we need to just add this to it. and in a sense put it in standard form. Okay, so again, you need to be familiar with the quadratic formula and factoring wherever you can. And we're not going to do all of these, but to see what they're like. Now, number 6 is interesting. I know we had some like this perhaps on our test or something. So what is that? Well, this is going to be 2 over x to the second plus 5 over x equals, and let's just put that on this side here, a negative 3 there equals 0. So the technique here is to get rid of our fractions, and our lowest common denominator is x squared. So here the x squares cancel out, and we're left with a 2. Here one of the x's canceled, and we're left with a 5x. And here nothing cancels out, so we're left with a negative 3x squared. And then we're going to shift everything over to the other side to make our x squares positive and change these signs. And a negative 2. All right, this might factor. And it did, factors into this. So we're going to equal this to 0, this to 0. Here we transpose the 1, that gives us a negative 1 over 3, and this one gives us a positive 2. And those are our answers. We didn't do this, and this is just equating this to 0 and either using the quadratic formula, which is probably what you would use there. Okay. All right, now they're giving us a little work on completing the square. And I know you have one like that on your test. So we had said put this underneath. Our x goes there. This sign goes there. What's half of 12? And then you square this, gives you 36. And this is just like so. This one gets a little more tedious because we have to take 1/2 of our b term here, which is a negative 2/5. So that's going to give you a negative 2/10, which is 1/5. So this is 1/5 there, negative. And if we square that, we get a positive 1/25. Got a little sneeze there. Let's see. So we take half of this. Half of that is a negative 2/10, which reduces to a negative 1/5. I could have put it there, but we'll use the system. Okay, solve by completing the square. We'll do one of these. So x squared plus 8x. The first thing we do is move our c term over to the other side. Put our parenthesis. X goes there, plus goes there. Half of this is 4. Now we square the 4 and get 16 that we have to add to both sides. So we now have this equals 2. We take the square root of this, plus or minus the square root of that. So we get x plus 4 equals plus or minus the square root of 2. Transpose our 4 becomes a negative 4. and our 4 is gone there, and that's our answer. This one would be a little more tedious, but half of that would be just this. Let's do it anyway. So once again, half of our b term is just 7 divided by 2. We're going to bring our 10 over to the other side as a negative 10. Square this, we get 49/4 that we add to both sides. So there we are. This will be this. And then we just have to make this with a denominator of 4. So that becomes 40. A negative 40/4, this will become 9/4. And we take plus or minus the square root of this side. And this, so we have x plus 7/2 equals plus or minus, this is going to be 7/4 here. No, that was 9. Let me just check that here. Yeah, 9/4, which is 3/2. And then we transpose that, and we get x then equals this or that. We simplify this. X equals -5, or x equals -2. Now, once we get something like this, we know we could have factored that. And I just wanted to show you completing the square anyway. And there are our two answers, a -2 and a -5. But we did it by completing the square. If we would have used the quadratic formula, we would have gotten the same answers. Now for number 13, they're asking us to use the discriminant, which is b squared minus 4ac, to determine the type of number and the solutions of this. So our b is 4, that we're going to square, that's 16. Our formula is 4a, which is 1. And our c is 12. So we then get 16 minus 48. So we get a -32 under the radical sign. So we're going to get 2 imaginary number solutions that are irrational. Okay. Now this one is to write the quadratic equation having this for a solution. And we just put it right in there here. So it's going to be the opposite sign of this. So that would be a -x minus 1. So when we transpose that, that becomes a +1 divided by 2. And then this one is x plus 3. So when we equal this to 0, the 3 goes over there. So we're just working backwards. Now we FOIL this. This is going to be 2x squared. My outers are a 6x. A -1x gives me a +5x. Minus 3 equals 0. And that was writing the quadratic equation, reversing the process. Once we know the answers, we just work backwards. Okay. That was a review of Chapter 8. Let's go on to 9. And let's see what we have here. Find the composition of f of g. And then later g of f, where these are our values. So we had just finished this, but again, a little review. So what we're going to be doing here is taking this function of g and putting that in the f function where the x's are. So we have to put it there. So that would be 2x minus 1. And then it's going to be minus. And then we're going to put the x there, which is 2x minus 1, the quantity squared. So we then expand that, 2x minus 1 minus, square this is going to be 4x squared. Multiply these and double it, negative 4x, and square negative 1, which is a positive 1. Now it's minus out in front, so we have to change all these signs internally. That'll become negative, that becomes plus, and this will become minus. And we can take away the parentheses. So we have here then a negative 4x squared plus 6x. This 4 and the 2. A negative 1 and a negative 1 gives me a negative 2. Now for the reverse of this, where we're doing g of f, this is what our x is. So it's going to be 2 times this, which is x minus x squared minus 1. So this is 2x minus 2x squared minus 1. And then we put it in better form. So a negative 2x squared plus 2x minus 1 is our answer. Okay. Number 2 is similar, and again, we don't want to make it too long. Determine whether this is a one-to-one. Well, I've rewritten it in slope-intercept form. Y equals mx plus 2. But whenever we have the absolute value of something, it makes a kind of V shape. So where this would be a function and pass the vertical line test, does it pass the horizontal line test? And the answer is no, because they intercept in 2 places. So this is not one-to-one. Okay, and then finding the formula for the inverse. Let me set this up. So the first thing is we change the function symbol to y, and it's in slope-intercept form. And then we reverse the letters. X goes to this side, y goes to this side, and then we solve for y. Well, we're going to go x transpose the 5 as a plus 5, and then just solve for y. So for number 4, it's y equals x plus 5 over 6. But here we use f inverse instead of the y. Okay? And let's do this one too. Again, we convert our function notation with a y, reverse the letters, and now solve for y. So our x transpose the 1 becomes a negative 1, and we have y to the third. And then we take the cube root of this and the cube root of the other side. So for number 5, it's going to be y equals the cube root of x minus 1. And remember, we replace this with inverse function. Okay. Okay, let's just do some general work on this. That if this were f of x equals 2 to the x power, then with our x values, without any plus 1 here, this would be if x is 0, this is a 1. If x is 1, then this is a 2. This is its reciprocal. If x is 2, this is a 4. And this is its reciprocal. So plotting that, and again, it would always go through 1, and then 2, 4, 2, 4 right there. And basically our curve is like so. Now, when you have a plus 1 here, this dot just gets transposed up one place, and then our line then, instead of it being at our x asymptote, which is the x-axis, moves up one. And that's basically what happens there. Now, for something like this is the inverse of this. So it would be 4 to the x power. And for that one, again, it would be here, but it would be, one is 4 now. That would be a 1, then it would be a 4, and then it would be a 2 squared, 16. So the curve would be like so. Now, since this is the inverse because it's log, our line is going to go through this one here, and it's like so. And again, you just have to pick out a graph since they will already have been done for you. But just showing you some basic skill of this, and hopefully you have them in your notes. Now in simplifying this, remember our old little model that our base, which is going to be 4, is to some exponent that will give you this answer. Now, if we're using the technique of exponential equations, so we can figure out what our exponent would be here, although they're not really asking us that. 4 to the what power is 256? And the answer is to the 4th power. 4 to the 4th is 256. Now let's do this one. 10 to what power is 10,000? Well, again, this is to the 4th power. 10 to the 4th power is 10,000. 10 and 11 are very similar, and 10 can be written in this form. And if you recall, we said whenever we have log base t, where the answer is t to the 10th power, the answer is just 10. This is just a 1, and it just becomes this. So writing this in that log form down here, this is just a 1, so our answer is 34. So in looking at number 12 now, we're changing a little bit. We're saying this is its logarithmic form. what would its exponential form be? Well, base b to what power is equal to 1? Now, what did we say the power of something that is equal to 1? Well, we said it was 0. Anything to the 0 power is 1. So for 10, it's 34, 11 is 10, and 12 is 1. Now rewrite as an equivalent logarithmic equation. Now for number 13, we're rewriting this as an equivalent logarithmic equation. So we're going to need the word log. What's our base here? 5. What's our base here? 196. Now remember, our log is going to equal the exponent. So what's the exponent here? Well, -3. What's the exponent here? 1/2. Now, what's the answer? Here it's 1/25. 1/25. And here it's 14. So we've converted from an exponential equation to a logarithmic equation. We went one way, and this is the reverse of it. Now rewrite as an equivalent exponential equation. We're reversing it. So what will our base be here for this one? Well, it's going to be 8. Our base is 8. And what's our exponent? Our exponent is m. And what's our answer? 64. So we already have an idea that this might be a 2, right? Okay, they're not asking for that though. Number 16. Our base is 5. Our exponent is 3. And what's our answer? 125. Again, some good notes here if you have a problem with it. Now, we just went over this the other day. We want to separate this and write it as extended logarithmic form. So it's going to be log base A, but we have to put our exponent out in front, so it's going to be 1/2. So 1/2 log base A plus our exponent out in front, 4 log of base B and then minus 2 log base C. Okay, as we do this one, we notice all of our logs are of base A. So log base A. Now we have this exponent to put by the m, so this will be 1/2. And we have this exponent to put in the denominator by our n, so this will be a 3 there. And for our p, we don't have anything. Now another way this might have been written, we could have said p, the square root of m, over n to the third. Another way. Okay, here they want us to do some evaluation of these. And I don't think I gave you any like this on the test, although there were some in the practice and quiz bees. But how would you do it? Let's just go through that. Okay, these are a little tricky because they're giving you these values. And then here it's 2 divided by 5. But remember, these are exponents. So when we are dividing exponents, we subtract them. So we're going to take our value for 2, which is this, minus our value for 7, or 5 I should say, which is this, and it gives us this value. That's the answer for 19. 20 was 35, but again 35 is 5 times 7, and when we write that, we're multiplying exponents, variables with exponents, we add them. So we're going to take the 5 and the 7, adding them up, and that gives us this. 28's a little tricky, but it's 2 times 2 times 7. So we have this, added to this, then added to 7. That will give you that answer. And 16 is 2 times 2 times 2 times 2, or in a sense you can just go 4 times this. Okay? All right. Kind of tricky, but interesting. Here, just follow the instructions, putting these into your calculator. For number 27, we're going to use the change of base formula, which is log of 85 divided by log of 4. And you round to 4 decimal places. And I did that. We got 3.2047. Okay. Now, a little bit of graphing again, because there are a few of these on your test. We're running a little over, but it's probably well worth your while. And for these to graph them, the key is this is function notation, and it's going to be up. Instead of going like this, where 0 is your x asymptote, it's going to be 2. So it goes up through 3. We've raised this up 2 values. These lines aren't super accurate, but to show you what it's like. And then here, when we said it was in a parenthesis, it's the opposite. If it was -2, that means we're going to shift it over. So now our vertical asymptote is 2, and it goes through 3, and it looks like so. So again, you just have to match your graphs, and these would be excellent little references for you. All right, to wind this up, here we have x to the second, or 2 to the x power. So 2 to the x power is equal to 2 to what power? Well, that's -6. So here x equals -6. And here for this one, we have 3 to an exponent. 81 is 3 to the 4th. So our exponents equal each other. Transpose the 3x, transpose the 4. We get 3x equals 1, x equals 1/3. Okay, under 35 minutes, so that was good. And good luck on your final exam.